Hello and welcome back to Statistics1. We are going to continue on our quest to organize data, and today we are going to take a look at organizing quantitative data, meaning numbers. So the quantitative data can be categorized as discrete and can be continuous, right? We collect the data from either population or a sample. In our case, could be, let's say, the shoe size for purposes of learning all of this. So consider shoe size. Where should we start? With what number? 7? 7-Eleven is a store. 3. We should start with 3. That's okay. We'll go all the way up to fireman. So, there's nothing wrong with that. Did I say anything wrong? No. If I convert into where I come from, I'm 40 something. So. All depends on which units used to measure. So, 3 to, is anyone beating 13 in this room? 13? Yeah. Nah? 12 and a half? Yeah, this is why you should not mess with me. 13 wide. Yeah. All right. So 3 to 13. Now, these are the sizes. Now, what we actually have is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So this would be the size. And then we are going to have, again, tally, which is going to be a number of people having each one of these sizes, and then we'll have the frequency, and then we're going to have relative frequency. So we can go around and we could all disclose our shoe size, but just in the interest of time, I'm going to assign shoe sizes here. So we're not going to do actual going from one person to another to figure all of these. We're just going to put whatever, and so let's go with 1, 1. Let's say nothing over there. Let's say 2 6s, and then 4 7s, and then 5 8s, and then 3 9s, and we'll go with 9 10s, 4 11s, 3 12s, and me. All right, good. So now this will be tally. Then we'll use this to come up with the frequency. So frequency of 1 1 0 2 4 5 3 9 4, another 3, and 1. So that's what? 10, 17, 20, 30. So apparently surveyed 33. So we have 33. And this is the way to represent quantitative data, because remember, shoe size, it's numbers, so it's quantitative data, and this is called a single value grouping. Now I understand there are 12 and a half, and we can include that and make this more robust, but whatever. So this is going to be called single value grouping. And I'm going to point the arrow from the title into the size over here. And explain here in parentheses one value at the time. Let me give you another example. Number of pets that you have at your home, right? So you go and you say, no pets. Okay, 0. Dog, 1, right? So you can go and collect. So what is the amount of pets that you would have? You can have 0 if you have none. You can have 1 if you have 1 pet, right? All the way up to, I don't know, 17 or more. We're talking cats. No, I have a dog. It's a very vicious dog. No, Yorkie. It will rip the Chihuahua and like nothing. These are trained killers. Like show it a rabbit or a rat, you'll just see fur fly around. That's what they're bred for, exactly. They are killing machines. Those are hunting dogs, Yorkies. They're trained to go into the rabbit hole and retrieve a rabbit. You try fit in the rabbit hole and retrieve a rabbit.
Is it a bloodline?
Yes, 5 generations. I have paperwork. So single value grouping, shoe size, right? It's not one size fits all, like hats. It's sizes from 3 to 13, and we have number of people assigned to those sizes. Then we have another example would be, let's say, number of pets. What is the example in the book? Number of TVs per household. You still know what those are, right? TVs, they're still around. Because now everyone's on the monitor and a cell phone. What's like now TV? I do have friends that do not have TVs. They just have computer monitor. Okay, fine. So that's one. And then we have the next type to organize data. So this is just organizing data, right? So single value. Then we have a limit grouping. And in the limit grouping, you want to consider intervals. So you can assign, those intervals don't have to be equal. So you would say a teenager, right? Teenager, that's up to 20 years old, right? Well, now it's kind of pushing 30s, but it should be up to 20. And then I guess adult, and then senior. I'm not sure at which, where these cutoffs are. And maybe you want to have a kid, and maybe you want to have a baby. So if you think there are ages associated with those, and those would be the limit cutoff points for you too. So I'm not sure exactly at which hour baby becomes a kid, and a kid becomes a teenager, and a teenager. Oh, actually, it's like when you're out of 12 and you become 13, then it's right. They should have 11 teen and 12 teen, but they don't, right? So it's like those are the two. So they're not in teens. So I think if you think about that, so age, let's go 0. That's at the production instant to the, let's say, baby. 1. Thank you. That's a short period. And then we have, so I'll put baby. Oh my God, you're going to go subdivisions? Okay, 1, 2, please enlighten me. 3. Okay, thank you. Toddler, is that 2Ds? Yeah, I don't remember anything from that stage. Then we have 4 to what? For a kid to, we said 13, right? Let's go to 12, right? I'll call it kid. Then 13 to 19. Teenager. If you live through that, 20 to, what are we going to do, the senior citizen? 65? No, adult.
So I'm saying the
64. Turn 65 to death. I forgot the A, yeah. Senior. And then after that, religion takes over. If you're religious. If you're not religious, then you're done. So these would be the categories. The only one I don't like over here is 1 and 1. It should not be 1 and 1. I know, but it's fine. 2 to 3. So you survey members of a town or something. You know, how many of each of these categories? So you still have your tally. You will have your frequency. You will have your relative frequency. And let's say this particular town, we polled 100 people. And out of those 100, there was, let's say, 16 teenagers. Right? Well, then the relative frequency would be 16 over 100. Right? No coughing. So, what? So we would, I was about to assign other ones, but who cares? So we'll see 16 out of 100, that's 16%, right? So we would say that about 16% are teenagers, right? And we can, now this is important, right, to look at demographics and all of the other things. The amount of kids, the number of kids is important because there are policies that you have to put in place because you might need extra schools, you might need less schools. Currently, we are experiencing less kids, physically less kids in existence. Therefore, some middle schools and high schools and so are closing because they don't have enough, especially in New York, right? They don't have enough students to go, and then enrollment in colleges is going down across the board. This is for all schools. The enrollment is going down, yes.
So if less people are going to college, why are you using them more valuable? Less people have to do it.
It's called work visa with someone that is that. We can talk more about it later, but that's technical. So it's and not being in the field that it's sought for, right? That's another thing. Yes. That's true. That's true. I have two friends who were both. One was a doctor, and the other one was a surgeon. They came in, so they're working. They're doing different. They're still both related to medical, and they're much better off than if they ended up being doctors again. But, but yeah, that's true. Same works for law. It's a different type of law, so that doesn't work. But technically, everything else, which is more. Nope. Your law degree is useless in your law degree is useless in many countries because it's different type of law. So we have the limit grouping, and the limit grouping would create these classes, right? And we stuff again. So you look at the subject, right? We said if it's a person, it's called a subject. And if the subject has 6 months, we put a tally as a baby, right? If the subject is 23, we go with the adult, and so on. So we have, so these are called classes. So each one of these is, that's a class. And then within a class, you have a lower class limit, upper class limit, and then the class width and a class mark. Now, the class width is something that you use if your classes are evenly spaced. So we can also, so classes could be evenly spaced, they don't have to be. So in this case, we used common markers, right, the language markers. But we can also just go and say, okay, 0 to 10 on a pile, 11 to 20 on a pile, 21 to 30 on a pile, and so on. You can do it that way. In each one would be the same width in this case. And you can go through, well, I can go 1 to 10, and right. So you can do that. So this is over here, same class width. And as I said, each one of these is called separately a class. So you have a class of teenagers, class of adults, class of seniors. And then for each individual class, you would have the lower limit and the upper class limit. I'll just write lower class limit and upper class limit. So you know immediately what. So if I take a look at the teenagers, so lower class limit, that will be 13 to 19 for teenagers. Cut point is just more specific, so they say under. So this is for continuous data. So cut point. Actually, there's no hyphen, just cut point. So cut point grouping. Weight categories for boxing, right? You don't want someone who's extremely light to go against someone who's extremely heavy. That's not fair, even though it would be funny to watch. So I don't know what the weight categories are. I have to look at it, but you would say under. So what do we have? 300 pounds, 600 pounds? Oh no, that's the sumo.
They have welterweight, heavyweight.
There's like a bunch, so they would probably start at like flyweight 125, middleweight 135.
That's exactly what I needed. So they start at 125, and then the next category is 135, and the next one is
145, 155, then it jumps to 170, then you go 185, you got 205, and then you got heavyweight, so that max is 285. So that's more.
yes, heavyweight. 285.
Yeah.
See?
Oh, wow.
Now, look at the way you have to write this. So you go 125 to under 135. under 135. And then you have 135 under 145. So this word under shows because there are smaller divisions within, right? And I'll just put the 3 dots here. Under. Your taxes work the same way. So I'll just say weight categories. Again, you categorize how many fighters you have in each category. Those are tally, and then you have frequency, relative frequency, and then you're done with the chart. So this is only how you're setting up the chart at the beginning. So the difference between the previous one, right, which was the limit grouping, you have the upper and the lower limit present, and then you immediately, at the split second of your birthday, you become, right, you stop being a teenager and you become adult, right, like a flip of a switch. Now here, you can be 144 pounds and what amount, ounces and so on, you are still under 135. So when do you want to weigh yourself? In the morning, when you are the lightest for the day, before you have the food intake and all of those kind of things. You weigh yourself in the morning when you are the lightest for the given day. Good. So that will be the cut point, and now we have the graphs for this, and the most important one would be the histogram. So that's the one that will be presented everywhere. Yes.
What would you wait for the last one? Like if that's the last 3 categories.
Well, you just say end over. There is no, right? So if you end up being 287 pounds and you are against someone 600, well, then just run. All right? Most likely they won't be able to catch up. No, I'm serious. Exactly. So now, histogram. And this is a big one, histogram. So that will be technically your bar chart, except for histogram, the boxes that you draw, they touch, because all of these categories are adjacent to each other. So if I am to draw the histogram, you would have a box, and then adjacent to it, next box, adjacent to it, next box, adjacent to it, next box, like this. So histogram boxes touch. And the reason why they touch is that if you are looking at your, let's say, weight categories, you have your 125, and then you have 135. It's continuous data into 145, 155, jump to 180, if I remember. No, 170. Jump into 170. So it's continuous data. So this weight is continuous, but it's still in categories, because as soon as you hit this mark of 135, you are going into the next category. And the same thing with taxes, right? Yes. So the histogram would be used for everything in this. You can use it for all of them, right? Number of we did the shoe size, right? Well, if you are not 6, you are 7. If you're not 7, you're 8. If you're not 8, you're 9. If you're not 9, you're 10, right? That's how it goes.
So when the shoe size, where we have 0 with the size 5.
There would just be no box. It would just be straight line on above the value 5. And then the next one will have a box for itself. Well, there is 0. So technically you are drawing the line on the 0 level. So it is touching. It's just there is no height to it, but it is touching because it doesn't mean that if I go next door, I won't find someone who has the shoe size that was missing in this particular classroom. Right? You know how Cinderella story goes. They had to fit that shoe somewhere, right? So just going around. Until she finally used that shoe in Ralph Breaks the Internet. You remember that scene? Yeah, it was all building up to that movie. Now the old story doesn't matter anymore. What else do we have? So next class, we will have to finish dot plot and stem and leaf, and then we're done. So 2 more things for next class to finish this. And then we'll do probably more examples. You didn't ask your homework assignment. Bring it next class then, together with all of this stuff. Be gone. Bye.